mom cat with you.
Okay, fine.
Yeah, and Pop is over there to enforce it.
The winds have been so shifty, it's just kind of waiting for a break for us here so we can get around this lump that not cooperating. It'll happen for you though. Yeah. Okay, well, we don't have much more time on these, so get right there. I'll your contact here shortly. And then we'll probably get back out.
The Greater Yellowstone ecosystem is an incredible outdoor laboratory for studying organisms. I'm interested in biodiversity, which has to do with the number of species you can find in a place, and I look at plants, birds, and butterflies. So this is one of the early emerging butterflies. It's called a pierid. It's a white butterfly. And when you hold it with the forceps, when you hold the wings with the forceps, it doesn't hurt them. We can let them go. We can basically release them on our hand. And, it'll acclimate for a few minutes and then it will fly away. I've been working here at the AMK for about 19 years in the Greater Yellowstone ecosystem. It's important to have places like this where we can see what the world is doing, where it's not as influenced by human domination. Obviously, there are human effects in this landscape. There's no place on the globe that's not affected by humans. But in this place, we can look at how species respond to environmental conditions, and we can assume that most of the responses we're seeing, especially in terms of the plant time that they're coming out, the butterfly emergence times, the number of species that we see around here, that's pretty much affected by natural processes. We're not worried about things like fragmentation of habitat. We're not worried about agriculture. We've got a relatively pristine landscape, and so we can look at how species respond over long periods of time, and that's the other thing I'm motivated by, is looking at long-term databases. So we're in Grand Teton National Park, in the northern part of the park, in a little road and valley area called Pilgrim Creek Road. And this is a relatively dry montane meadow, elevation about 7,000 feet. There's a lot of blooming flowers here, and so it's a great habitat for butterflies. And we've been doing a long-term study of one butterfly species called Parnassus clodius, which is the Clodius parnassian. The common name is almost the same as the scientific name. And this is a species that has been undergoing some declines in Europe, in places like Poland and some of the other European countries. In the Grand Teton National Park, the populations are doing relatively well. So we're able to do a long-term study where we do mark recapture. What we do is we actually capture the butterflies with a net like this, And we're able to handle them very carefully using some forceps. And we can mark them and let them go, and they go off flying on their own. And then we come back day after day to monitor the size of the population. The males come out before the females, so that the males come out sometimes even 2 weeks before the females. One of the things we're concerned about in the context of climate change is an asynchrony, meaning bad timing between when the males come out and when the females come out, as well as an asynchrony between when the host plant comes out that the caterpillar eats and when the adult butterflies are out. So you can see that the soil here is really dry. There's a lot of cobbles, and the plants that are surviving here are just making it, and most of the moisture that they get comes from the snowfall. So if conditions would change, if snow melts too much earlier, or if there's less snow accumulation, these plants might not produce such vibrant leaves or flowers. So from the perspective of the insect community, there could be big changes. If the plant community changes, you could see big changes in the insect community. This is arrowleaf balsamroot, which is a pretty predominant species around here. It's a relatively early summer blooming species. It's doing very well right now because this winter we had quite a bit of snowpack. So this is an important nectar source for a lot of the butterflies in this meadow. We can look at the conditions of the meadow right now and say there's quite a bit of nectar out here. It looks great, but the number of individuals that we see this year flying around as butterflies are dependent upon the number of eggs that were laid last year. And last year was actually a bad year for the butterflies. So we're going to just have to wait and see what happens, because I'm suspicious that there could have been a smaller number of eggs laid last year. So next I'd like to take you over to see some of the research plots. We have 4 different treatments that we're using to simulate some of the potential effects that could be witnessed as a result of climate change. So one expected trend could be that there would be less snowpack. So we have one treatment that involves snow removal. We come out here in the first week of May and actually we remove snow with shovels from the plots, and that allows the ground to warm up faster. The second treatment involves warming structures, which are passive warming structures. They're called open-sided chambers, and these involve no electricity, no solar power. It's just basically the sun coming through these little plexiglass windows, basically, that warms up the soil just a little bit. The third treatment is including both snow removal and warming, and so we'll see that as well. And then finally we have a treatment that involves no treatment at all, so that's a control, and we use that to compare as a baseline to these other treatments. So my students over here are collecting some data on the temperature and the moisture of the soil. So we have probes, and you can see these various sticks in the ground, but they're connected to cables that monitor the temperature of the soil and the moisture of the soil at various depths within the soil. We've also got some temperature stations that monitor the air temperature at various levels. Over here we have a warming chamber, and this is an experimental plot that included both the snow removal back in May as well as the warming that's occurring throughout the growing season. And if you look down here, you can see that the plants are a lot further along. They're taller, and they're further along in their phenology with respect to blooming. We can compare that to this plot here, which was a control, and the plants are not quite as tall. The flowers are just beginning to bloom over here on the balsam root, and you can see that they're not quite as far along. So here's an example of a balsam root that's just beginning to flower. So we would say that the phenology is delayed in this plot, which is a control plot, compared to this plot over here, which has both snow that was removed in May and the warming conditions. So some of these plants are woody plants, for example, like a sagebrush, which would not show as much of a response because this is a plant where the vegetation will be out all winter as well as during the summer. Some of these other plants pretty much die back completely during the winter and then reemerge in the spring. So we would expect that a species like the senecio would show the similar kind of response as the balsam root to these kind of experimental treatments. So we're looking at all of these different plants to see how they respond to various treatments. So being able to do the same exact thing year after year after year, which might sound boring, but it's the only way we can learn what's really happening, because there's so much variation in the natural world. It's only after we have long-term databases that we can actually begin to understand what are the drivers behind some of these changes that we see in the natural world.
Companies like GE and Babcock, Wilcox, and Westinghouse hit data to the point where after the plants were already started, to correct the deficiencies was going to cost more than $1 billion. We're talking 1970s dollars. So that was an enormous amount of money. And the utilities started complaining to the attorney generals in their state, who then sued the Westinghouse and GE and so forth to recover the damages that their utilities were suffering from. So it wasn't anti-nuclear sentiment that caused the financial problems with the industry. It's, as you say, it was not studied, pushed too hard. Over the years, and was covered up by the Canadian nuclear program. And the chief executive officer for Ontario Electric said that his engineers operate like a cult. That's what the